Hello, ladies and gentlemen. Today we're going to look at special segments in a circle. If you have two chords like line segment AB and line segment CD intersecting at a point in the interior of the circle, call it point E, then what you should know is that AE times BE or EB is equal to CE times, excuse me just a moment, okay, times ED. In other words, this part on this chord times the same part on the other chord will equal this part on that chord times the other part on that chord. Okay, all right. And that's what's given to you down here. If you look at it, AB times BC equals DB times BE, same difference, all right? So that's what I would do is when I was doing these problems, I would name these points. I'd say, okay, here's A, let's call that point B if you like, and there's point C. Don't get caught up in thinking it has to be chord line segment AB. It does not. We'll call this point D, and we'll call that point E. All right, and the theorem says that if we stay on the chord line segment C, then the small part AB times the longer part of that chord BC, excuse me, will equal to, now we go to the other chord, which is DB, that little part times that bigger part BE. All right, and then we substitute in what we know for each of these values. All right, we know that AB is 3 and that BC is 6 and then that DB is 2 and that BE is X, and X needs to be, not squared, okay, just X. All right, so when we do, we get 9 is equal to, or excuse me, 3 times 6 is 18, is equal to 2x. And then we divide each side by 2, we get x is equal to 9. All right, let's go to number 2. In number 2, I'm going to name all these points of interest, and I'm just going to kind of name them at random. All right, D, and we'll call this point E. So if we stay on chord line, that short chord, line segment AC, we would do AD times DC. Notice you can write it differently. You can do center dot or whatever makes you happy, okay? It's some indication of multiplication. All right, don't leave it out because it would be doing writing the name of some kind of quadrilateral maybe or something. All right, equals, now we go to the other chord, which would be little part BD times bigger part DE. Oops, that's an E. All right, so AD is X times X equals BD is 2, and that radius is 10. Now, if that radius is 10, all right, then if you take segment, I'm going to name that circle K. If you take segment KD plus DB, they add up to radius line segment KB, which is 10. And if BD is 2, you subtract that to get the distance from K to D, which is 8. All right, so DB would be 8 plus 10, which is 18. So that means that x squared is equal to 2 times 18 is 36. Then we take the square root of each side to undo that square on x, and we get x on the left and 6 on the right. Let's go to number 3. In number 3, all right, you don't have to write the letters if you don't want to. You could do little part 6 times longer part x equals 8 times 8. All right, and many people wouldn't even write 8 times 8. They just write down 64 and be done with it. And then if you divide by 6, all right, x will be equal to 10 and 4/10. All right, 10 and 4/10, but I don't want to, well, you can write 10.4 if you want, or you could do 10 and 2/3, 4/6 would reduce to 2/3. It's all good, either way you want to write it, okay? Whether you want the decimal, okay? Wait a minute, 4/10, that's not right, that's 4/6, which would be 2/3, which would be 0.3 repeating, excuse me, 10.3 repeating. Okay, now I believe it wanted us to round to the nearest tenth, so that would be x would be approximately 10 point, that's 2/3, 0.6 repeating, isn't it? 2/3. Okay, so 10.7, I believe that's the one they would want, but you can give the exact answer 10 and 2/3 or 10.6 repeating, same difference. All right, let's go to number 4. In number 4, we're going to start on this chord with the positive slope, and we would do x times this x plus 7 equals 3 times 6. And when we distribute with this x on the left here, we get x squared plus 7x, x squared plus 7x. On the right, we get 3 sixes, which is 18. So then we subtract 18 on each side, and that gives us, oops, that's an equal sign there, x squared plus 7x minus 18 equals 0. Well, I'm going to try to factor, and let's see what we get. Let's see if it's factorable. Well, I know that x squared is x times x. To get a negative constant term out here, the signs have to be different, so I'm going to make that immediately. A factor pair of 18 has a difference, because these signs are different, of 7 is 2 and 9. The bigger one needs to come after this symbol, which means that 9 goes here and that 2 goes there. All right, and then you take each factor and set it equal to 0. And this first one gives you x equals 9. Well, x represents a distance up here, and that's extraneous, so we ignore that. This other one gives us x equals 2. All right, and let's check that. Now, I didn't box that one in. All right, so let's check it. If this is 2, then that's 9. 2 times 9 is 18. Is that the same thing as 3 times 6? And the answer is yes. Okay, let's go to that next one. All right, notice that it looks like they might intersect at the center, but it doesn't matter. If you have two chords that intersect in an interior point, all right, if that's a radius, so that's also 5. So 5 times 5 will equal, that's 5 as well, because that's a radius, 5 times x plus 2. Which means 25 equals 5x plus 10. Subtract 10 gives you 15 on the left and 5x on the right. Divide each side by 5. You find that x is equal to 3. Now let's check it. Oh, if you put a 3 here, now of course you could have just said, hey, that's a radius. That's equal to this 5. That would have worked as well. It would have been a better way, really. Okay. All right, let's go to number 6. And I'm going to do the work for number 6 up here because I've run out of room down here. All right, if that radius is 7, all right, that means this is 7. And if this is 2, that means this little part right here is 5. So if I were to do 2 times, now I need to add that 5 to that 7 to get 12. So 2 times 12 has to equal x times this part over here. Well, if that diameter is perpendicular to that chord, it's the bisector, which means that this segment's congruent to that one. And since that one is x, this one is x, and that means 2 times 12 is equal to x times x, or x squared. You could have written either one. So x squared equals 24. Take the square root of each side. You get x on the right. 24 has a perfect square factor, namely 4. Square root of 4 is 2, so I'll write that down, and 4 goes into 24 6 times, so it's 2 times the square root of 6. Now, since they wanted us to round it to the nearest tenth, you could do it either with the square root of 24 or with 2 times the square root of 6. You'll get the same answer either way. Okay, so let's do that. 2 times the square root of 6. Oops, I don't think I put the 2, excuse me. 2 times the square root of 6, or if you like, the square root of 24. It's the same, and they wanted us to round that to the nearest tenth, and that would be 4.9. Okay, so number 6, x would be approximately 4.9. Now here's both your exact and your decimal approximation. Let's go down to number 7. In number 7, this part on that chord with the negative slope, 2x, times that part, 3x, all right. Let's go to the other chord, and the one with the negative slope, and do this part here, 6, times that part, 5, all right. That would give you 6x squared on the left and 30 on the right. Divide by 6. X squared would be equal to 5. So x would exactly be the square root of 5. All right, and they want us to round to the nearest tenth, so we type in the square root of 5. That would be 2.2. Okay, so x would be approximately 2.2. There's both your answers. Okay, let's go to number 8. This little part on the chord with the negative slope, x, times this other part, 3x, has to equal 8 times 6. Okay, so that means 3x squared has to equal 48. Divide by 3 gives you the equation x squared is equal to 16. Take the square root of each side, x is 4. And you could check that. 3 times 4 makes that 12 for that little part. And 12 times 4 gives you 48. That's the same thing as 8 times 6. And now you know you've got it right. Okay, let's turn the page. On the next page, you're given two different formulas, okay? And this is where they intersect. When you have special segments like two secant segments that are, well, I don't want to call them secant segments. Two segments on a secant, on different secants, all right? And what it tells you is this, all right? This theorem says that the external part, this is the way I like to think of it. If I use that upper secant, all right, the external part times the whole, all right, of that one, all right, will equal to the external part of the other one, the one with the greater slope, all right, times the whole on that one as well. That's what I like to think of that as, all right. But it says if two secants are drawn to a circle from an exterior point, then the product of the measure of one secant segment, and I think they're talking about the external part, or the whole segment, they're calling it a secant segment, okay, times its external part will equal the secant segment, AE, times its external part, all right? So you can think of it two different ways, all right. You'll get the same answer either way. The second theorem says, if a tangent segment, segment AB in this case, and a secant segment are drawn to a circle from an exterior point, then the square of the measure of the tangent segment is equal to the product of the secant segment and its external part. Excuse me just a moment, okay? All right, so if you take the tangent segment, AB, and square it, that will equal to the whole tangent, or whole secant, excuse me, AD, times its external. Now, you may see that AC times AD. It really wouldn't matter, okay? That's what those two theorems say. Now, let's go use them. Okay, all right. In number one, we have a tangent, line segment PY, and a secant, line PT if you like, okay? So we need to take that tangent, PY, square it, and that will be equal to, all right, the whole secant segment, which is PT times the external part PM. That's the theorem on the right over here at the top, this theorem. Okay, so 3.3 squared, okay, so 3.3 squared equals PT. Well, that's 2.2 plus x, so x plus 2.2 times the external part PM, which is 2.2. All right. Now, if you want to, you could go ahead and divide by 2.2 on each side. That looks like what I would do already. All right, because if I do that, oh, well, yeah, you can do that. You'll get x plus 2.2 on the right, and I'm going to use my calculator to type in 3.3 squared, all right, divided by 2.2, all right, that gives you 4.94, okay, so that's equal to 4.94, all right, and then all we need to do is subtract 2.2 from that, or 4.95, excuse me, I didn't look. All right, and now all I got to do is subtract 2.2 from that, and when I do, I get x is equal to 2.75, and since they wanted us to round to the nearest tenth, that would go to 2.8. All right, let's go to number two. In number two, we have two secants, okay? And the way I like to remember it is the external part, 16, times the whole secant, which is 30 plus 6 and 6 is 12. 30 plus 12 is 42, okay? From that secant, we get the external part, TA, which is 18, times the whole thing, which is x plus 18. All right. So I'm going to go ahead and do 16 times 42. 16 times 42, all right, is 672. So 672 equals 18 times x plus 18. I'm next going to go ahead and divide by 18 on each side. All right. Now, the reason I'm going to do that is because that number 672 is sitting right here. I'll just divide it by 18. All right. And that gives you 37.3 repeating is equal to x plus 18. And now all I need to do is to subtract the 18 from each side. Okay. And when I do, I get x is equal to 19.3 repeating. But since they wanted us to round it to the nearest tenth, that means x would round to 19.3. Okay? All right, let's move over to number 3. In that part, you have two secants intersecting at a point in the exterior of the circle. All right? And I'm going to take that upper secant and do its outer part, 8, times the whole secant in L, which would be 8 plus 8, because that's 8, which is 16, all right, will be equal to the external part here, 6, times the whole, which is 2x plus 6, all right. And you can do one of two things if you want. You could distribute, or you can divide by 6. We'll distribute first, okay? All right, if we do 8 times 16, that gives you 128. If we distribute, that would be 12x plus 36. So now I'm going to subtract 36 from each side, okay? So that just means all I have to do is subtract 36, and that gives me 92 is equal to 12x. So then I'm going to divide by 12, okay? All right, so divide by 12, all right, and I get 7.6 repeating, and when I round that to the nearest tenth, I get 7.7. Okay, all right, let's go down to number 4. It's a tangent segment. All right, and a secant segment. So the square of that tangent segment, 13 squared, equals the external part of that secant, 9, times the whole, which is 9 plus 5x, or 5x plus 9, whichever way you want to think of it. 13 squared is 169. 9 times 5 is 45. 9 times 9 is 81. So we need to take 169 and subtract 81, all right, which gives us 88. So 88 is equal to 45x. So now we divide by 45. So divide 88 by 45 gives us 1.95 repeating. 1.95 repeating equals x. Okay, which means that x would be approximately, to the nearest tenth, 2.0. Okay, all right. Let's move on to number 5. In number 5, I'm going to use that external secant, the upper secant. The external part is 6. The whole thing is 4x plus 6, and that would be equal to 6 times x plus 3 plus 6, or if you like, x plus 9. All right, so 24x plus 36 is equal to, that times that's 6x, that's 9, plus 6 is 54. All right. I'm going to subtract 6x on each side to get the variables on the left. That will give us, I believe, let's see, 18x. All right. On the right, I'm going to subtract 36 as well. And 54 minus 36, let's see, it takes 4 to get the 40. 14 4 is 18, I do believe. All right. So 18, and then we divide each side by 18. We get x is equal to 1. All right. I'll do that last one, number 6, but I'm running out of room, so I'm going to do it over here. All right. If we take, it's a secant and a secant, so we take the external part of that upper one, st is 8, times the whole, which is 10, is equal to the external part of the lower one times the whole, which is x plus 11. All right, so 80 is equal to x squared plus 11x. That means 0 equals x squared plus 11x minus 80. All right, I'm going to try to factor if I can. Okay, all right. Okay, can we factor? Let's see. 0 would be equal to x times x to get x squared. The signs have to be different to get a negative. I need a factor pair of 80 that has a difference, because these signs have to be different, of 11. Well, 80 is 8 times 10. That difference is 2. Or 4 times 20. I don't get it. So what I'm going to have to do is use the quadratic formula. All right, the quadratic formula says x is equal to the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. All right, and I'm going to have to write that above because I've run out of room. All right, so x would be equal to the opposite of this b. And by the way, this works for ax squared plus bx plus c equals 0. And that's what we've got right here, okay? All right, standard form. So x would be the opposite of this b, negative 11, all right, plus or minus the square root of b, which is 11 squared, minus 4 times this a, which is 1, times that c, which is negative 80, divided by 2 times this a value 1, okay? That means x is equal to negative 11 plus or minus the square root of. All right, so I'm going to do 11 squared, that's b squared, okay, minus 4 times 1 times negative 80. All right, and that will give me 441, all divided by 2. All right, now I'm going to take the square root of 441. The square root of 441 is 21. So that gives me x is equal to negative 11 plus or minus 21 divided by 2. And that means you got to separate it into two parts. You got to separate it into the adding 21 and then the subtracting of 21. So I'll come over here and do that right here. All right, x would be equal to negative 11. I'm going to do the subtraction first. All right, that would be negative 32 divided by 2, which would be negative 16. Now, x cannot be negative because it represents a length down here. All right, at the bottom down here, you can see it represents that length. Since x is the distance t to q, you can't have a negative number. So I need to take x is equal to negative 11 plus 21 and divide that by 2. Well, negative 11 plus 21 is 10. All right, and 10 divided by 2 is 5. So x equals 5 is the answer for number 6, okay? All right, if you have any questions, please call me, email me, show up in a Google Meet, whatever you need to do. Thank you, and have a good day.